Hello everyone, welcome to the next video. The last video I did talked a lot about molarity, and today we're going to talk about molality. Yesterday you probably got an assignment that talked about the difference between molarity and molality, and I had you watch a Tyler DeWitt video. He does a great job of explaining why do we need molality and what is the difference between molarity and molality. Today we're going to talk a little bit about calculating molality. Molality is very similar to molarity. The only difference is instead of having moles over liters for molarity, we have moles over kilograms for molality. So in this example where it says what is the molality of a solution of 15 grams of sodium sulfate dissolved in 125 grams of water, the first thing we have to do, like we did before, is convert our 15 grams of sodium sulfate into moles. And you can see that we actually do that rather quickly, where we take the 15 grams of sodium sulfate and we convert it to 0.011 moles of sodium sulfate. Once I have that done, I also have to convert my grams of H2O to kilograms. And you can see that I did that. I took 125 divided by 1,000 and got 0.125 kilograms. I then use the triangle that we have up here and plug my numbers into the triangle to take my moles over my kilograms, or 0.11 divided by 0.125, and I get a 0.88 molality for this particular problem. One thing to note is that when I'm talking about molarity and molality, molality utilizes the little m and molarity utilizes a capital M. Very subtle differences, but ones you're going to have to know and recognize in the near future. Let's go ahead and go back to our 15.2 worksheet, and let's take a look at problem number 9. Problem number 9 is the first problem that deals with molality. And it says, what is the molality of a solution containing 75.2 grams of silver perchlorate, AgClO4, dissolved in 885 grams of benzene? One of the biggest things that people struggle with is which one is my solvent and which one is my solute? What is being dissolved in what? Which one do I have to convert over to moles? The one that is smaller is almost always, or I shouldn't say almost, it is always going to be your solute. Okay, the one that is larger is going to be your solvent. That is the one that is doing the dissolving. So the first thing that I have to do is I have to take my 75.2 grams of solute, AgClO4, and I need to convert that over to moles of AgClO4. And we know that we do that by dividing the molar mass of AgClO4 to figure out how many moles I have. The molar mass of AgClO4 is 207.4 grams per 1 mole. And when I calculate this out, I get 0.363 moles of AgClO4. Now, to find molality then, it's moles over kilograms, and I know my moles is 0.363 moles, and my kilograms, I'm just going to move the decimal 3 places to convert my grams into kilograms, or divide by 1,000, and I get 0.885 kilograms of solvent. After I calculate that, I get 0.410 molality. That's it for today. It's nothing new. If you have any questions, please feel free to email me and get a hold of me, and we'll try and work something out. Thanks.